You guys, welcome back to my YouTube channel. Today we'll be dealing with ventilation. This will be introduction, example 1, fluid mechanics and 6, right? So to determine, okay, so we're given a formula, right? It's given 5.6.5.6 formula to determine the frictional resistance in a duct. As you can see, when you're dealing, you should be given a fan duct. As you can see there, it's a duct, right? So that will be your duct there. So if you are given a duct, you must know that a pressure, as you can see, pressure, that one, it's a pressure. Frictional resistance is simply just a pressure. You see, they've included the bracket to show you this is the pressure. Is measured in what? In Pascal. K, K there, it's a friction factor. Here it's a friction factor, is measured. It's approximately to this if you're not given, but in most of the question, I don't want to lie, they will give you. But if you are not given, you're supposed to know is 0.0227 Newton second squared per meter to raise to the power 4. So then we have S again, which is the what? It's a rubbing surface in square meter, right? Rubbing surface. You must know why this is square meter. I will show you why it is in square meter. This is square meter there. Square, remember, square meter. This is a square meter. So we have this V there, which is a velocity. It's a velocity or of air or air velocity, or it's a velocity, or depend on that. Then area is the area of a duct. You must make sure you see we're talking about duct. Must be a duct. You see the duct in square meter. Obvious area must be in square meter as always. So this is what you are given. So you must be very careful why we have rubbing surface a square meter. Why do they say square meter? Is because the rubbing surface it's equal to perimeter multiplied by the length. Would be perimeter multiplied by length. Length is perimeter is measured in meter, and also the length is measured in meter. When you multiply this, meter multiplied by meter will be meter squared. That is why there will be meter squared. You must know that perimeter is this will be perimeter multiplied by the length. That is the rubbing surface, right? So question 2 here, we have air and the fan power. Fan power, as we know, work is force multiplied by distance. We know this one. Work per second is force multiplied by velocity, which is equivalent to power. But work per second simply just power. Again, this can be power, can also be power, right? So yes, can also be power. Then with the way F force is in Newton, you know, velocity is in meters per second. Or be in terms of water gauge, as you can see, air power, this is air power that we're given here, is measured in weight per gas gauge there. We have this formula there. We'll discuss about this as we are dealing with question. Do not worry about this a lot. Do not worry about that. Let's check in example 1. What is important here? Example 1, given a fan duct. You see they say a fan or fan extracts. It's not a fan. A fan extracts 9.3 cubic meters per second air through a duct. Here it's a duct. Now we have a duct there, which is we are given that its diameter is 79 millimeter, right, and 49,3 long. This duct, we are dealing with duct. You see the duct. The duct is in diameter. That means the duct is a circle. You see, our duct can do like this. This is our duct. Must be very careful there. This is a duct. Then this duct, it has a diameter. We've given a diameter, right, and it has the length as you have given them. As you can see, the length there is this. What is the length there? 49. It's 49,3 meter, which is the length. This is simply just length. What about this diameter here? As you can see, will be this diameter. You will see 79.3 divided by 1000. This will be 0,793 meter. It's for the duct. It's a diameter of a duct. D duct. It's a diameter of the duct. This one, diameter of the duct. Must be very careful of the duct. Would be 0,793 meter, which is this diameter. This diameter there. So that is what we are given. Then they says again, if the coefficient of friction is 0,00225, find the pressure required. Find the pressure required to overcome the friction of the duct. We know the pressure is this one, as I have said. Here it's our formula that we'll use. I said PR is a pressure. So the formula that we'll use is said that will be, we know that pressure is the same as PR. It's just a pressure. Also, it's equal to a pressure K S V squared A like this. Whereby this, it's our coefficient as we are given. S, it's a rubbing surface. S, it's a rubbing surface. I said S, how to calculate S, I said it's a perimeter multiplied by the length. So we must check here. We're given in what? A duct, cross-section duct. You focus on this cross-section of this duct. This cross-section, you see what is what? It's a circle. So you must, how to find a perimeter of the circle, of a cross-section of the circle. How to find perimeter of a circle. You must know how to find the perimeter of the circle, right? Perimeter of the circle is equal to pi multiplied by, I mean diameter multiplied by pi, or pi multiplied by diameter. It's one and the same thing. This is how you calculate the perimeter of what? Of the circle, right? So then we know that the perimeter, since we're dealing with duct, we're focusing on duct. Our duct, it's a cross-sectional area, it's a circle, right? So this will be pi multiplied by, will be diameter multiplied by pi, or pi multiplied by diameter. It's one and the same thing, multiplied by the length of the duct. The length of the duct that we are given there. So this, the diameter is set is 0,793. We have given multiplied by pi. Then the length, what is the length? Are we given the length? Are we given the length? Yes. Here it's the length 49,3 multiply this 49,3. Then this will simply just, when you punch your calculator, will be 122,8,82, right? Obviously set is measured in meters squared. This is what we have there. Hopefully you see there. We have that S, we are done. K we are given. And what about the velocity there? How do we calculate the velocity? How can you calculate the velocity? We know that the velocity, or you can say you know that Q is equals to area, right? Rate of flow is equals to area multiplied by velocity. Then you make velocity the subject of the formula. Then what is Q? Are we given Q here? Here we are given, which is fine. It's in cubic meters per second, which that is 9,3. What about the area? You can calculate it separate if you want. Area is simply equals to pi over 4 multiplied by d squared multiplied by d squared. Then this is pi over 4. What is the diameter? Diameter, we're focusing on the diameter of the duct, which is 0.793. We will square this, what your diameter will be 0.494 meter squared, right? This is what we have. Then you divide this by 0.494. This is what is V. Punch this on your calculator. Supposed to get that V, which is the velocity, will be equals to 18,83 meters per second. This is what you have. So you have all of this. Now you can substitute. You've calculated velocity in the area. Sorry about this noise. It is raining outside. Let me finish first this video. Now we know that pre-K we have given, which is they've given us, which is was 0.00225 multiplied by, we know, let me just write the formula first quickly. So we know this is what is Ks V squared divided by area, right? K is simply the friction, right, which is it was 0.00225 multiplied by surface area. We've calculated it, which it is 122,82 multiplied by velocity, which is 18,83 squared. You square that, then the area is 0.494. Then you punch this on your calculator, punch all of this on your calculator. Supposed to get that your pressure will be 198,3 Pascal. So thank you guys for your time. Sorry about the noise. It is raining. Please do not forget to subscribe to my YouTube channel and stay notified whenever I post the new videos. So this is what it is, guys. Thank you.